welcome everybody in this new video. I hope you've all worked out the assignments with the arrays, and I hope that you found out how to use the help function in the context help to let you go quicker through all of the function palettes in LabVIEW, because honestly there are so many functions in LabVIEW that it's almost impossible for me to explain only 10% of them. So you need to be able to figure it out yourself. Alright, so I hope you were able to complete the assignment. In this video I want to show you an example of creating a moving average. Alright, so I created this VI, and this VI might be coming familiar for you, because what's going on here is I'm generating a number between 0 and 1, which is multiplied by 10 and then is rounded off to the nearest integer. Then I'm actually either adding that number or subtracting that number from the same input, depending on whatever number is generated here. So if a 0 is generated, then I will subtract. If a 1 is generated, I will add the number. Then the number is displayed in this waveform chart, and it's connected to the loop itself because it's used with a shift register. So the value that comes out of here is then feedback into the shift register at the beginning of the loop, and that's what's actually being added or subtracted from the generated number. Right, so if I run this loop right now, you can see that it continuously is displayed in this chart, by the way. You can see that it continuously randomly goes up or down with a random amount. Alright, actually you can see if I run the loop and if I stop the loop, it continues where it stopped actually the last rounds. I always like to initialize the loop by zeroing it, and I do that actually by feeding a 0 into the shift register, which is creating a constant 0. That means that every time I run my program, this loop can only start, because of the data flow, it can only start once it has its value from this constant. So it's not that the loop is going to start and later I'm feeding in the 0. No, first the 0 is fed into this loop and then the loop is started. Alright, so if I run, you can see in my chart that it resets to 0. And so this is the 0, and then it starts running. Alright, so this is a cool random number generator, and we can of course generate a array from this by just connecting it to the edge of the loop. Oops, yeah, there it is. And then do tunnel mode indexing, which is one way. There's actually a different way, and that's actually creating the loop or creating the array inside the loop itself. So we can already start making averages, we can start making means, we can determine the mean. So we can do that actually in the loop. The calculation is going to be a little bit more difficult for the PC, because it first needs to execute its random number generation, then it needs to feed it into the loop, then it needs to calculate a mean. And in the beginning that's not a problem, because we only have 100 measurements or 1,000 measurements. But if we're going further and further and we got more measurements and we got 10,000, 100,000 measurements, which it goes there really rapidly if we're measuring at the fastest rate as possible, then the calculation can become a little bit increasingly difficult. So it can slow down the process. So I wouldn't actually recommend the acquisition of measurement data and also the analytics of the measurement data in one loop, but we'll get to that later. First, let me show you how I actually make this array inside the loop itself. Alright, so we go into the array palette and we're going into the insert into array. And if we place this array in here, then we need to follow the index of the loop. So we're going to follow the wire the loop iteration up to this index input, which means if the loop is 0, the first time it starts, it actually fills in this value first. So what value are we going to insert in this array? And that's of course the value of the randomly generated number from the previous iteration. And then the output is an array. I'm gonna wire this up to this loop tunnel. Oops. Alright, I'm really bad at selecting the loop tunnel. Alright, so we got an array here. But of course we want to see the array. Let me first create an indicator. Alright, and if I run the loop now, I actually can't run the loop because I need to insert an array here. And this array that needs to be inserted in here, for example, let me just create a blank array. Create a constant. We have a blank array here. Alright, if I run the loop right now, then we're going to have a problem because every time we run the loop iteration, it starts at 0 again. So what does that mean? It means that, okay, we're zeroing or creating a empty array, and then we're going to add a number into the specific index, and then we're going to display the array. But that means that every time we run the loop, we initialize the array again, and that's not working in this case. So how can we actually change this? By using the shift register, because we want to use this array that we're creating here. We want to use that same array with the values from the previous iterations. We want to use that in our loop again. So we're gonna change this to a shift register again. Select it, shift register. And we're going to remove this. I'm gonna place it outside of the loop for a second and wire this up. Alright, and because I want to do exactly the same as I'm doing here, which is creating a starting at 0 every time I'm starting the measurement, I'm gonna wire this empty array up again and so on. Alright, if I run it right now, then you can see I start with the 0. Let me expand this a little bit. Alright, so I'm initializing the array every time, so I start with 0 and then I'll start generating numbers. Start with 0 and start generating numbers. And I stop the loop every single time right now because this array is not actually, even though it fills up, it's not automatically moving with the adding of new values. Alright, but for now this works. And now we have the array inside the loop as well, and it's constantly new values are added to this loop or to this array. And now we can do the same thing again, where we're just going to, for example, to get an average, we're just adding the array, adding the elements, and then dividing by the size of the array.